Good morning. I should be able, you can hear me? Can you see the desktop?
Yep.
Okay, great, thanks. Okay, so welcome back. I hope you had a good vacation. All right, okay, got everything set up. Now, let's see. Uh, there's another midterm exam next week. So the first thing I want to point out is that there's a review sheet for another midterm exam. Uh, if you look at the syllabus says that there'll be the second exam on April 1st. Okay, so April 1st is a week from Thursday. Okay, so at the end of next week. So it's a week and a half away. Okay, so exam a week from Thursday, and here are like the last exam. It's gonna be very similar. Whoops. Oh, I didn't check ahead of time. Let's see. I wonder if it's up there or not. No, I forgot to copy it to the web server. I have to copy it after class. Okay, so okay, so here's what it looks like. I'll code it up there after class. The exam is going to be on Thursday, April 1st. Okay, and it's going to be on, so it's going to overlap with the last exam a little bit. So it's going to be chapters 4, 5, and 6 from Think Java, and these sections from the other book. So there's the links to the material that the exam is over, and then here's a list of what the exam is going to talk about. Okay, and then there's a bunch of review problems. Okay, so like the previous exam, most important thing to do is solve these problems. And if when you're working on those problems, you can ask questions about them. They're review problems, they're not the exam itself. So uh, make sure you can solve these problems and ask questions. Ask me questions, or if you have a friend in the class you can talk to, you can talk with them about the problems. But just make sure you can solve these problems before the exam. Okay. So and like the exact same, I won't put up an answer sheet. So I'll answer questions and I'll let you know if you have a right. If you show me a solution, I'll tell you if it's right or wrong. You can ask me questions about your solution, but I'm not going to put up a list of answers because I don't want people to just memorize answers to problems. Okay, so work on them, solve them, but ask questions if you have any problem with them. Okay, and uh, there right now the list has got about 20 problems in it. Okay. Okay, so that's the most important thing to now is that there's this exam coming up, and right now, yeah, right now they're not up there on the web server, so I'll fix that link right after class. Okay, and then there's a reading assignment to read we're going to start another topic on Thursday, arrays. Okay, so that's a real important topic, something really new, something very different than what we've been doing so far. So we'll start a new topic on Thursday, and there's a chapter on it in this book, and also an introduction to arrays in this book too. Okay, so two different introductions to arrays. There's you can read about them in this book and also in this book. So two good explanations of what arrays are. Okay, all right. And what we're going to do today is do a little bit more with methods. Okay, we're going to do a little bit more to talk about methods. Now, um, here's what we want to here's a review of methods so far. These are the words that are like, well, yeah, these are the ideas that we need to talk about in methods. And most of these we've talked about, but there's one kind of idea in here that we haven't really talked about real well, the method return values. Okay, but okay, so a method has, you know, you have to first define a method and then you call the method. So there's two big important ideas. You give a definition for your method and then you call it. Like let's look at an example from last class. Okay, so in the last class, we drew one of these patterns. So let me download this example. Okay, so let me save it. So this, we did a pattern using a method. Okay. So here's the code that we wrote in class last week or just before break. Okay. The code, drew this pattern. Okay. Okay. Now here's the method that drew the pattern. So that there is what we call the method definition. Okay. Then over here, I called it to say, do this work here. Okay. So this is when by its, like, if I copy this up into the Java visualizer, it's a little bit easier to run if I put it up in the Java visualizer. Okay. Okay. All right. So this is the method definition by itself. For example, if I get rid of the method call, so for example, here's the method call. If I comment it out, this is still a program. Okay. If I visualize execution, Java, but nothing happens. There's nothing to do in the main method. This is a method definition, and this is a method definition. This one's called by Java for you. When you run your program, that method gets called. So when I say visualize execution, or if I run it in Dr. Java, when I click the run button, the Java system calls that method there. Okay. Now that method had nothing to do in it. Okay. But notice that this method is just sitting there. It doesn't get done unless I call it. This code doesn't get executed unless somebody tells the Java system that it should be executed. This is executed automatically, but only the main method is. Like if I delete this entirely, now I do have a problem. If I click visualize, I get an error message saying we don't have anything to do. That doesn't mean that this is not a valid Java program. It's a valid Java program. It just doesn't run unless some other program runs it. Okay. This by itself is a Java class holding one method. It's a valid class. It's a valid method. But unless some other class calls that method, it doesn't do anything. Okay. Now, if I put back this, now I've got Java will be happy because now there's something to do, even though there's nothing in it. It'll call this method and there won't be anything in there. Okay. Now in your head, if I uncomment this, then now this method calls this method. So Java will jump into that code. Okay. So now Java calls this method automatically. So the visualizer starts at the first line. Then the first thing this method does is it calls that method. Okay, so I get down here to line 10 because I call this method. Okay, so back over here, we separate the idea from the method definition from the method call. In one place in your program, you have to define the function, the method, and in another place in your program, you have to call the method. Okay, so someone has to define it and someone has to call it. Another example of something like this, let me bring up a real simple little Java visualizer program. Um, okay, I'll just use like imagine if I define a string variable. Okay, there's a string variable. I can call a method on that string variable. So I can say string s2 equals s1.2 uppercase. Okay, now that's a method call. Well, Okay, there's a method call. See, that would be the method call. Well, where's the method definition? Okay, somebody had to have written the method definition. And the method definition for two uppercase and string is part of the Java system. It's just buried in Java. When you first installed Java at the beginning of the semester, you installed a folder on your hard drive. And in that folder are definitions of all these built-in functions that come in, all these built-in methods that are part of Java. Somewhere in that folder are hundreds of thousands of lines of code of all the method definitions for all these built-in methods. Same with like if I create a scanner and call next in. Okay. So here, oh, and when you what did I do? Oh, okay. When you step, notice that when you step into this, when you go forward, like here, when I'm over here and I say forward, I go into the method definition. See if we go here into visualize. Oh, I have too many lines of code in this thing. I really, this is printing 20 lines. I should make that just something like 6 lines. Then it won't take so long to run. Okay. When I call this method, the visualizer jumps into it. When I call this method, the visualizer doesn't jump into it. The visualizer doesn't jump into the methods that are built into Java. It only shows you the methods that you wrote. Okay. So it only steps into here because you have the code for it right here. So if you make a method call and the method is in your code, the visualizer shows jumping into that code. So it jumps from there to there. Here, the visualizer just does it. Okay. It called that method, but it jumped to that method, but the visualizer didn't show that happening. Now, Dr. Java and some other visualizers can actually show you the code for that two uppercase is in Java. The code is in there, and it is possible to step into it, but most times you don't want to. You don't want to see what's inside two uppercase. So, like the visualizer doesn't even try to step into it, though. If they wanted to, they could have a little button here that said, like, let me see what's inside of the built-in methods. Okay, but they didn't put a button like that in there, but they could have because there is code for two uppercase. You just don't see it normally. When you step through in the visualizer, you just usually don't want to see that. You're interested in the code you wrote. So you're interested in what you wrote, not what was written for you. Okay? So every time you call a method, somewhere there has to be the method definition. Okay. And first, when we were learning about methods, we learned how to call methods. We started with talking about calling methods. Now, sometimes methods have parameters too. So if this was a method that didn't take any parameters, I could also call a method that's built into string. Okay, like substring. Substring takes two methods, where to start and where to end. Okay, and if I visualize this again, it's not going to it's just going to we say step over calling to uppercase. It just calls it and gets the result. Same with substring. It's going to call it with those parameters, okay? And just, we just see the result. The Java system had to go into that method with those parameters, do the work, and get a return value, okay? All right, so method call, these are the ideas involved in a method call. You have the flow of execution is the idea that you have to step from here into the method body. Okay, so you have to step from here into the method definition. That's called the flow of execution. It happened here. We just didn't see it. We left line 6 of this program and we jumped to some line of the substring method and started executing it. Okay. Then you have to pass argument values. Okay. So in this case, 2 and 7 were passed to substring, okay? And then you have to have, now, see, the argument, we use the word argument values. 2 and 7 are the argument values. They're passed to some parameter variables that are inside the substring method. Like maybe the person who wrote it called them start and end. Like maybe they called this variable start and they called this one end. But in the method definition, there are parameters. So the method call has argument. The words we use are, there's arguments in the method call, and then those arguments are put in the parameter variables in the method definition. Okay. And this is called passing. This is called parameter passing. You pass argument values to parameter variables. Okay. So you have argument values in the method call, you have parameter values in the method definition, and when you call the method, you pass the argument values to the parameter variables. Okay. And then you could have a stack diagram of that. Now the visualizer, over here, it's showing you the stack diagram for main. Okay, it's showing that what main is building up its local variables. So like if we go back over here, we can see this happen over here. There's an argument. Let me go back to the beginning. Okay, there's a argument value. There's another argument value. Now, when I call this method, 6 gets passed to size, and the pound sign gets passed to C. Okay, size and C are what we call the parameter variables. Okay, and when I call this method, now we'll see it happen. If I go down here, 6 got passed to size, pound sign got passed to C. Okay, that's this pass argument value to parameter variable. Okay, so we can see that there's arguments, parameters, okay, and then when we call the method, we pass the argument to the parameter, pass the argument to the parameter. Okay. The argument value gets put in the parameter variable. The argument value gets put in the parameter variable. Now, if I can, let me change this a little bit. Suppose I create a int s equal 6, and I use s here. And then I say char C1 equals pound sign. And I use C1 here. These are still argument values. See, the terminology can get a little bit tricky. Notice we say that you have argument values, but these look like variables. Okay, but what's really happening is that variable, Java, first thing it does is say what value is in this variable. So it looks up the variable and says that's 6. So what it really passes to this is not s, it passes what's in s. So it computes the value of that variable. Same thing here. That's not a parameter variable, or that's not an argument variable, that's an argument value. Okay, so it's an argument value. Because what Java does is says, well, I have to figure out, first thing you do when you call, before you can call this method, this is actually done one step before you call the method. Java says, what's the value of this? What's the value of this? The value of this is 6. The value of this is pound. Then those are the argument values. So this really works out to be what we had before. So this really is pattern 8a of 6 comma pound sign. So Java really first turns this into that and then calls the method. Okay, so you always have argument values. There's no such thing as argument variables, but those argument values are put into parameter variables. These values are put into those variables because all this code here knows only the variables. Okay, so that's called parameter passing. You evaluate if there is a variable here, you evaluate it to its value. If there is a variable here, it has to be evaluated to its value. Okay, and actually, I could even do funny things like, um, okay, okay, that's still 6. Okay, now watch, see if I visualize this. See, okay, here I'm going to call the method. What Java is really going to do behind my back is do all that addition first and get the parameter value and then pass that parameter value down to here. It doesn't make size 1 plus 1 plus 1 plus 1 plus 1. It does this calculation first. It needs to find the value first and just says, okay, size is 6. Okay. So before this method is called, before you jump to the method, you compute what the value of that argument is, and you compute the value of that argument. Okay? Right. So these are kind of important ideas, especially as we learn more and more programming. We have to keep track of all these things that are going on. It's actually important that this calculation gets done before you call that method. So, for example, this could be another method call. You could have a method call that gives you the argument to that method there. Okay, it's real common to do things like that. To have this be a method call that computes something, and then that something becomes the argument to this method call. Okay, right. So, and then notice that we've got the stack diagram over here. So this is the stack for main. We were at line 7 in main. That's where we were to jump into here. Now we're at line 12 in pattern, and we're about to do the for loop. And we've built up these local variables, and there's more local, like here's another local variable, this loop index. Okay, so this stack diagram here shows us that in the in the middle of main, we made a jump to pattern. Okay. When pattern is done, we'll go back to line 7 in main. Okay. That's part of the flow of execution. Okay. You flow from one method into another method, do the work in that method, then flow back to where you came from in the previous method. So we'll go back to main. Then main could call this main could call main could do another method call. So then you would go from here back to here, maybe then back up to here. So that's the flow of execution from one method to another method. Okay, right? So a method call, you flow from one method to another. You have to evaluate the argument values first. Then you pass the argument values to the parameter variables. The stack diagram shows you that. The stack diagram shows you how an argument value got passed to a parameter variable, argument value passed to a parameter variable. Then over here, this is not an argument value, that's a local variable. Okay, that's a local variable in the method. Okay, and that actually could be one of the other ideas in here is that there are local variables. Okay, methods have local variables, and the local variables are part of the stack diagram too. Okay, so the stack diagram will be the parameters and the local variables. Okay, now, and then most of these ideas down here are mirrored in ideas on the for method definition. If you look at the method definition, it also has pieces to it. This first line here is called the method declaration. Okay, so the method definition is in two pieces. The first line called the declaration, whoops, then the braces surround what's called the method body. Okay, so the method declaration is the line just before the method body. The method body is what's inside the pair of braces. So like here for my main method, there's its declaration, and there's main method's body. And here's my method's declaration, and then here's its body. Okay. Oh, actually, I'm sorry. The body, I missed one brace. The body went up to there. Okay. So there's the method body for that method. So the method definition is the two parts together. You have to have a declaration and a body. Okay. Now, in the method declaration, there's going to be three parts to it. The method declaration has, excuse me, the method declaration has three parts to it. There's the name of the method, which is kind of in the middle of things. Then there's the return value. Okay. Well, actually, I right here. There's the name, the parameters, and the return type. Okay. So there's over here in the picture, here's the name, parameters. The name goes just before the left parentheses. The parameters go in between left and right parentheses. And in front of the name is the return type. And then in front of the return type is public static. For now, we'll always put public static in front of the return type. We'll see later what those mean. We actually aren't even saying yet what those two words mean. So the word public and the word static, we're just they're there. See, they're there here, and they're there in all our methods. Okay, so they're not we're not really saying what they mean yet. So the method, from our point of view, this is the method declaration. Its name, its parameters, and what it returns. Now, this thing doesn't return anything. That's one of the things we want to talk about today, is be more precise about this return type. Okay, so so the method declaration has three parts: name, input parameters, and return type. Okay. Oh, and each input parameter has two pieces to it: what type it is and what you want to call it. Okay, so this guy is a int that I'm calling size. So it's an integer that's counting the size of the pattern. And then this is a char C. So its role is to be what I print in the pattern, and it's a character. Okay. So I have to say what type it is. I give the variable a name. The name hopefully helps you understand a little bit about what the variable does. Like here, calling that X wouldn't be very helpful. I could change all the code to use X there, but then it would just make it way harder for people to figure out what's X doing. X, if I call it size, whoever reads this, if when they start reading it, they realize, okay, that represents the size of something. They might still have to figure out what it's the size of, but they at least realize it's determining how big something is. If I just put X there, they have no idea what X could be. You know, is it counting something? Is it the size of something? Is it what is am I going to print the number X? Am I going to add it to something? It's an it's an integer, it's a number, but you have no idea what it might mean. So you should always use good variable names to have people a sense of what the variable actually does. Okay. So every parameter has a type and a name, and the name should be helpful in understanding what it does. Okay. Then you have the method body. Okay. The method body goes between the braces, and that's where the code goes at what the method does. Okay. And in the method body, you could have local variables, just like I said down here. There could be local variables. Now, we've talked a little bit about scope of a variable. The local variables, like in this, when we go down here to visualize, notice that there isn't a variable I yet. It isn't until I go here, now I have a variable I. The scope of I is this for loop. Okay. No, for example, I don't have a J yet. Now I have a J. Okay. Now, as I loop a little bit, oh, notice that notice I have a J, and then it goes away because see, now I'm in this loop. Now I'm out of that loop. The J belonged to that loop. That's called the scope of J. So here we see that we're at the beginning of the loop, and we have a j variable. But this loop didn't do anything. So right now, this loop is printing the no spaces. So it was printing 0 spaces. So right now it's printing 0 spaces. So the loop just it looped 0 times. But the key is that the variable j, its scope is this loop. So when that loop loops 0 times and I go from that loop to this loop, my j disappears and I get a different j. Now I get a different j. And if I loop a few times in here, now I'm about to leave this loop. Okay. See, I left that loop and j went away. That's the scope of the variable. The scope of the variable is in that loop. This j variable only lived until line 21. Okay, so there's one j for this block and one j for this block. So they have there's two different j's with different scope. Okay, now the scope of size is all of this method. Okay, but the scope of size isn't down up here. There is no size variable up here. You can't use size up here. This variable here only lives in this code. It only lives in it only lives in this code here. The scope of size is that box. The scope of of C is that box. Okay. You can't use size or C up here. Okay. The scope of S is that box. You can't use the letter S down here. S won't have any meaning down here. S ends with the scope of a variable always ends at a brace. Okay. So this variable scope goes to here. This variable scope goes to there. And you can't use C1 down here. You can only use it after you've declared it. Okay. So you can only use a variable after you've declared it, and you can use it up to a closing brace, and then the variable goes away. So that's what we mean by the scope of a variable. Okay. Then the last thing here is return value. And that's what we haven't talked about. That's what we want to talk about a bunch more today, is what do we mean by return values? Okay. What do we mean by return statements? Okay. That's the last part of talking about methods. This is all the ideas that are in methods, and this is the one that we haven't really said a whole lot about. Okay. All right. So let's now these methods all were void. See, void, void, void. So these are methods that don't have a return value. So not all methods actually have a return value. Okay. So they have a return type, but they don't have a return value. Okay. So all methods have a return type, but if the return type is void, then you don't have a return value. So let's see what we mean by that. Let's be precise about that. Okay, so let me close these examples. Okay, so I'm going to go ahead. I'll go back to the visualizer and write another simple program. Okay, I'm going to write a method that calculates a formula. So public static. Now, here's where I'm going to change things. I'm going to write a formula that computes an integer, and I'm going to just call the f for formula, and it's going to take in an integer x and an integer y. And I'm using x and y here because it's going to be like a math formula. So I'm going to use math like variables because these x and y's are just going to be representing something like in a math formula. And here's what I'm going to do. I'm going to take x, say multiply it by 2, and add to that, say 3 times y. So there's a formula, 2x plus 3y. Okay. I want to return that as an answer. So I want this method to do this calculation. So if you call this function, this would be essentially what in a math textbook will be written as f of x, y is the function 2x plus 3y. Okay, so essentially, and then later, after you have a formula like that in a math book, you can say, well, what's f of 2, 3? What's f of 0, -1? Okay, what's f of 0, 0? Okay, you can do calculations with your formula. Okay, you could even do things like you could say f of 0, 0 plus f of 1, 1. Okay, you could do even fancier formulas. You could say f of 0, 0, comma, f of 1, comma 2. This is what I was saying about earlier, that you could have, this is actually a method. In math, this would be a function. The input to this function is this number here, which I compute by taking this same function and giving it those numbers there. So f of 0, 0 is going to be 0. 2 times 0, 0, 3 times 0, 0. So f of 0, 0 is 0. So this is the number 0. And this is the number, well, 1, 2. So this would be 2 plus 6, it'd be 8. So this is the same thing as f of 0, 8. So this is the same as f of 0, 8. Okay, and f of 0, 8 gives you 2 times 0, 0. This gives you 24. Okay, so this is the same thing as this, which is the same thing as this. But we'll see these in a second. We'll do the calculations. Oh yeah, this one here would be the same thing as, well, f of 0, 0 gives you back 0. That's the return value. And f of 1, 1 gives you back 5. So that just gives you 5. 5 plus 0 is 5. Okay. Now, now, if I want this to give me back an answer, I have to put the return keyword in front of there. So I have to say this method should return that answer. Okay. So now I've got a method declaration that says the name of my function is f. It takes in two parameters, which are integers, and it's returning an integer. And then the method body is real simple. It's just one, in this case, it's just one return statement that returns the value that this function is. Okay. And then up here, I could do these calculations. Like I can say f of 2, comma 3. Now, if I just, now, f of 2, 3 doesn't mean anything to Java by itself. Like if I try to compile this, I'm going to get an error message. I need to put a semicolon after that. Okay. If I try to compile it now, oh, it worked. It compiled. What it's going to do, it's going to jump down in here. It's going to do the calculation. Okay. It passed 2 into x, passed 3 into y. There's the stack diagram. There I see I jumped from line 4 of main to line 9 of f. There's the parameters passing. Now it's going to calculate 2 times 2 plus 3 times 3. Okay. So notice it's going to return 13. Okay. So 2 times 2 plus 3 times 3 going to give me 13. 9 plus 4. Okay. Now it's going to return now to where it came from, but there's nothing to capture the return value. So the return value just goes away. Okay. Notice that it said here that it's returning 13. When I get up to here, nothing happened because I didn't do anything to save the 13. I didn't do anything to capture the return value. There's a couple different things I could do to capture the return value. I could have a variable y to hold it. This is most usually what you do is you have a variable that holds the return value. So now if I go back over here, I go down here, do the calculation. I'm about to return 13, and there's 13 stuffed into the variable. Okay. Notice that the visualizer does kind of a funny thing here. I'm at line 9. this method is about to return. So all these variables are going to go away. The x is going to go away, the y is going to go away, and the return value is supposed to go into to y. Now notice that there is no y in main yet, because up here the visualizer is doing this right-hand side. It hasn't done this left-hand side yet. So it hasn't actually, at line 4, we're really in the right half of line 4. We're in this half of line 4. We haven't done that half. So there is no y yet. So now when you click forward, you go back to line 4. Now notice that everything from this function disappeared and the 13 disappeared because there's no y to put it in yet. So this is kind of a quirk of the visualizer. We just finished this right half, and the right half has said its value is 13, and visualize about to create the left half. So it creates the y now and puts 13 in it. Okay, but that intermediate step, when it's just blank like this, sometimes it causes confusion. Sometimes when you're trying to figure out what the visualizer is telling you, you get these steps where right after you return from a method, the method you return from disappears, but the value it's returning disappears also. So there's the 13. It's supposed to be returned. The method disappears, the return value disappears, but then it reappears. There are times when this is really confusing. It's not that confusing in this simple case, but when you're doing more complicated Java programming, this is actually kind of a quirk of the visualizer, that this thing that you're returning from here to here disappears and then reappears. Yeah, it doesn't really disappear. This is just a way the visualizer is showing it. The 13 never disappeared. The 13 was always there. The visualizer just didn't have any place to show it. Yeah, the visualizer right now, the 13 is in a temporary variable inside the Java system. It's about to copy it into there. It's really in a temporary variable that we don't know about. The temporary variable was used to hold what was transferred from here up to here. Okay, so the visualizer doesn't have any way of showing that temporary variable. So the return value just disappears on us and then reappears. Okay, and that'll sometimes cause you, if you're not careful, if you're not realizing that the visualizer makes the return value disappear for one step, it can get confusing. Okay, all right. So we've seen all the steps of it. Now, we've seen all these things here again. The flow of execution. We watch the flow of execution. We're flowing from here down to here. We pass these arguments to these parameters. We did the calculation, and then now we do the new thing. The new thing here is the return value. Okay, return value of the method passing something back to where it was called from. Okay, the method call passing information back to where it was called from. Okay, now let's do some of these other ones. Like suppose we did something like this. Oh, now let me show you another thing. Here's another way to get to see what this thing did. I could print it out. Now, this is not really as useful because when you print something out, it's not part of your program. It's part of the output. It's not part of the program. So, for example, I could print f of 0, -1. Now, printing is not the same thing as storing things in a variable. And a lot of students get mixed up the difference between this. This shows you the result, but it doesn't let you use the result. The result is disappeared on it. It appears on an output screen, but the result isn't part of my program anymore. So this is actually not always that useful thing to do. This saves the result. I can now use it in my program. Printing is actually something programs do very little of. In the real world of writing code, you almost never use print line. Programs don't print out things. They do calculations, and when they call methods, they use the results of the methods to do more calculations. Okay, there's massive amounts of calculations, and then there's just a little bit of output. Okay, so printing things isn't as useful as you might think it is, because the basic idea is that now this return value is not part of my program. It's part of the output screen. So if we visualize this, So the first function call, first method call, gave me a return value. So the return value is in my program. Okay. Now I'm going to do this one. So I'm going to go back down here with -0 and -1. So x is 0, y is -1. Okay. I'm going to calculate the return value of -3. Okay. Now that return value is going to disappear. Okay. I'm up here now. Okay. And now what I'm about to do is take that return value and print it out here. Okay. But it's not part of my program. It's part of this output. Okay, that may be okay. That might be what I want, but I have to realize that when I print something, it's not part of my code anymore. It's down here in an output screen, or maybe it got printed to a file or something, but it's not something that I can make use of in my program. Okay, usually it's better to save the return value in a variable like here, and then maybe you could print the value, but you want to keep it, you want to make sure that you usually need these return values in a variable so you can make use of them. Okay. Now let's see, what else can we do? We we have another variable to hold another return value. Let's do something like this one here. This is going to make us call the method f 2 times. This one line of code is going to make 2 calls to that method and get a return value there and a return value there, and then add up the return values. So it's going to call the method 2 times and then add up the return values. Now, let me skip through the first part. Now, here's one thing that's interesting. When you return from that, there'll be a return value. The visualizer won't have any place to show it to you. So it'll disappear, and then you'll go into this function and call and create another return value. And then when it returns, there'll be a second return value, which the visualizer will make it disappear. And then the visualizer will add those two return values and it give us the result here. We won't see this guy's answer, and we won't see this addition happen. Okay, so let's watch. Okay, so now we're in from line 6, we're in F with 0, 0. Okay, so we're going to return 0. See, we're going to return 0. That means we're going to go back up here to line 6. This is now a 0, but the visualizer is not going to show us that. See, we're back to line 6 now, but now we're actually over here and about to do this. So now I click forward and I'm going to go back inside here. See, now I'm here with x11. I'm doing this now. Now remember, this thing returned to 0, but it doesn't show up anywhere here. This thing's going to return a 5. Okay. Now I'm back up here. This thing returns 0. This thing returned 5. Java's about to do the addition of 5 plus 0 get 5, but we don't see anything. We don't see, this is what I'm talking about, how it's a little bit confusing. You don't see that there's a 0 here, that there's a 5 here, and you're about to add 5 and 0 and get 5. Okay? See, you didn't see that happen, but you have to, so that part you have to fill in for yourself. The visualizer helps us see things, but it doesn't show us everything. The visualizer isn't everything there is to see. So here we know that there is a return value from there, and we just have to remember in our head that there's a number there that's the result of f of 0, 0. There's another number there that's the result of f of 1, 1, and then this thing adds those two results, and they store it in y. The visualizer shows us the final result. It showed us doing this work and doing this work, but it didn't show us those return values. Like right here, right now, we're at line 6, and this is the case where there's a 0 representing that blue strip there, and there's a 5 representing that blue strip, and it's about to do that sum, but we don't see any visual information about that. And then you finish line 6, and you see that y2 is 5. Okay, so the visualizer shows you a lot, but it doesn't show you everything. Okay, doesn't show you everything. Oh, let me show you one little trick. Okay, I said, let's see, go forward. Let me get to line 6. Okay, right now, I just entered line 6. See, I just got there from line 5. I'm at line 6. I'm about to do this piece. And then I'm going to eventually do that piece. But how do I now see but it just shows me I'm at line 6. I'm back, let's see. Okay. I'm at line 6. I'm at line 6. I'm at line 6. Okay, but every time I was at line 6, I'm at a different place. I was here, then I was here, now I'm here. Okay. You can get Java to show you can get the visualizer to show you that a little bit by doing something kind of weird, by breaking this thing up into separate lines. If you break this up into separate lines, the visualizer will show you what line it's on. In fact, I can even, there's actually, let's see if, I don't know if it'll, okay. So, yeah, there's all these different lines. There's the left-hand side and there's the right-hand side. The right-hand side is that piece, and that piece. Okay. So let's visualize it this way. And the visualizer will show us a little bit more. Nobody's going to write their code like this, but the visualizer will show you a little bit more. Okay. So now I just, now I'm at line 5 and I'm about to do this calculation. So now I'm down here doing that calculation. Okay, now I'm doing the print out. So there's the printout. Okay, now I'm here. Okay, all right, now click forward. Now I'm at line 6. Notice that the first thing to do is move from line 6 to line 7. So you notice that before there wasn't a movement. Before we went from line 6 directly down here into the method. But now we're seeing that, oh, before you can compute y2, the first thing you need to do is compute f of 0, 0. So I'm at line 7. Okay, then line 7 sends me down here. See, I came from line 7. Okay, I do this return, I get the return value 0. Now I'm going to go back to line 7. Okay, now there's a 0 in place of that. So I'm putting a 0 in place of that. Now what's next? Line 9. See, I went from line 7 to line 9. I have to do the right-hand side of the plus. Okay, so I'm at line 9. So the visualizer is showing me a little bit more here. By writing the code in this kind of funny way, the visualizer is showing me just a little bit more. I'm actually at the 9. Okay, so now that sends me back down to F. Okay, do the calculation, get the return value of 5. Well, it goes back to 9. Okay, now what's there to do after 9? Well, now there's the plus to do, and then after the plus, there's the equals to do. Now, I don't think the visualizer is going to, I will see, I don't think it shows us those steps. But there, first there was this, then there was compute this. Now there should be a computing of a plus, 0 plus 5, and then there should be stored in y. But let's see what it does from line 9. Then forward, done. See, it went from line 9 to line 10. So it did that last step and that last step. Didn't show us, it didn't go back to line 8 and didn't go back to line 6. Someday I hope they could fix this, because it actually should have gone from line 9 to line 8, because that's the next thing to do the addition. Then after you do the addition, it should have gone to line 6 to do the assignment. Put the answer in y2. Put 5 in y2. So there really is, do that calculation, do that calculation, do the addition of the results, put the answer in y2. So there should have been 1, 2, 3, 4 steps, but we only saw 2 steps. We saw this step and this step, but there really should have been 4. Okay, so normally you don't write the code that way. Normally you would just write it like we had it before. If you want to, you can compare them. The way it was before looked like this. This is the way you would normally write the code. Okay, and then you could do it this way to make it, this way kind of visualizes it for you a little bit better. That way, that breaks it down into its steps, and the visualizer shows you that step and that step as separate steps. Okay. Now let's do another example. What happens if we, like this one is kind of funny here. Let's see what this would do. Okay, I'm going to put it before these. Okay. How's Java going to think about this? Let's see, I'll put some spaces in here to make it a little bit easier to read. Okay. F takes in two numbers. See, F takes in an X and a Y. What's the first number that this F takes in? The result of that. I'm going to change this from 0, 0 to 1, 2. Instead of getting back 0 all the time. Okay, make that 1, 2, and make this one 2, 3. Okay, so we get back different numbers. Okay, so notice that we're going to call F 3 times. Before we can call F here, we have to call F here and get that argument to F. Then we have to call F here and get the second argument to F. Remember, I said you have to get the argument values before you can pass them to the parameter variables. Okay, so this call to F needs a value for that parameter, and this call to F needs a value for that parameter. This parameter is that one. So so we make this call with that in for X and that in for Y. And that'll give us back what? 5. Okay, so this will come out, this will evaluate to 5, and this one will evaluate to what? 13. Okay, right? So then you'll call F with 5 and 13. So this actually works out to be F of, did I do that right? 5, 13, I think, right? Yeah. Let's see how much the visualizer shows us. Like it won't show us a 5 sitting there, and it won't show us a 13 sitting there, unfortunately. Okay, and also the visualizer will just keep returning to line 7, even though it's going to return to line 7 a lot of times, because there's going to be this call, this call, this call. Now we could break this up into separate lines, and then we'll do that in a minute and see a little bit of the sub steps. Let's just see how it looks like this way. Okay, let me get up to line 7. Okay, so we're at line 7. Now, we're at line 7, and we're about to jump into F. But you have to be real careful. We're not this F, we're going to be this one. So watch. Forward. Okay, I'm from line 7, I'm in F at line 22. But where did I come from? There's an F here, an F here, and an F here. The visualizer is not very clear about that. You get a little bit of a hint to see, oh, X is 1 and Y is 2. So that means, oh, it was this F. So I'm in the method, and I'm actually doing that F. So I'm down here in the method, and I'm actually doing that one there. Okay, and I see it from the parameters. Okay, so that's going to give me back the 8. Oh, I thought it was 5. Oh, I was thinking 1, 1. Yeah, I kept thinking, yeah, this is an 8 over here. I had wrote 1, 2, and I kept looking down to the formula and doing 1, 1. Okay, so that's an 8. Okay, notice that, so there's the return value. So there's an 8 in that blue box. Okay, now there's an 8 in that blue box, but Java Visualizer doesn't show me that. It's about to do that. Okay, now it goes back down here to line 22. See, now we're at line 22 from line 7 again. Now, but this time we came from here, and we see that the parameters help us see that. X is 2 and Y is 3. Okay, so there's going to be a return value 13. Okay, now I'm back to line 7 again. Now I've got, now I don't see it over here, but there's an 8 here and a 13 here. Okay, and I'm now about to call F from here. There's the 8 and 13. See, there's the 8, the 8 that was here got put into that X, and the 13 that was here, the Java didn't show us, it shows it to us now, that's in the Y. So there's the 8 and 13. The return value from him is actually this one, and the return value from this is that one. Okay? And now you go forward, there's going to be a return value of 55, and now we're back to line 7 again. Except now what we're doing is this part here. We're actually doing that part there, putting something in. See, notice that the method disappeared and our return value disappeared again. See, the return value 55 disappears and then not reappears as the value of y1. Okay. Now let's do that one more time. Let's put the line, I'm sorry. Let's do the same kind of trick. Let's put this on a line by itself and put this on a line by itself. That's an 8. And now Java's gonna, the visualizer will be a little bit clearer about line numbers. They'll be a little bit clearer about line numbers by doing this. Okay. Okay. So let's visualize it. Now we're doing these examples in a lot of detail because this is actually a pretty non-trivial idea. Keeping this flow of execution in mind, how methods work, this flow from the calling method to the method definition. You're in the method definition, then you return something back to the calling method. Okay, to where the call was. You have to keep it. There's actually quite a bit of ideas here. Okay, there's really quite a bit going on. So we're doing these examples in a lot of detail, and hopefully seeing it beat to death like this over and over again, it starts becoming natural to you. You start thinking this way, because it isn't a natural way to think. These formulas, these formulas, especially in math classes, you don't think of them as being necessarily done in lots of little steps. It's jumping around. What we want you to start thinking here is how thinking stepwise, a formula like that means, oh, first you compute this. So that means first you plug 0 into X. So first you take that 0, plug it into X, you take that 0, plug it into Y, you do a calculation, you get an answer here. Then you go over to here. You take that 1, plug it into X, you take that 2, plug it into Y, you get an answer, and that goes here. Now you take those answers and you plug that answer into X, you take that answer into Y, and you compute that F. You start thinking of all these steps going on, which isn't, even math classes don't talk about all those steps very often. They don't think of it in terms of all these little mini steps involved, but that's what a programmer has to do, because this is a simple example, but as the examples get more complicated, to understand them, you have to really think of all the steps. Okay, so we want to get down to this line 7, the one we were doing. Okay, so let me get up to line 7. Okay, now I'm at line 7. Okay, well, what do I do first? Well, I'm not doing this guy first. I'm doing this first because I need that argument. I need that argument to this one before I can do that one. Okay, so Java goes to line 8. See, it skipped over that F and went to that F. Now it's going to do now it's going to go down to here with X equal 1 and Y equals 2. Okay, now I can see that I came from line 8. Now I see, yeah, I came from this, I'm sorry, I came from this one. Okay, then get the return value. Okay, return is 8. Okay, I returned 8 to that slot. There's really an 8 sitting there now, which it has disappeared, but there's really an 8 sitting there. So the next thing I need to do is go to the other F. See, now I need to go to line 9. So I need to do the other I need to compute this argument. Okay, so I'm at line 9, and I go down here, do a calculation, return value is 13. So now there's an 8 sitting there and a 13 sitting there. And at this point, I can go back to line 7. Actually, I should have made this two separate lines because that 7 is different than that equal y. So now I'm actually gonna go to this one here. Okay. Actually, let me go back. I should have made that like that. Okay. Because there really is this step here, then this step here, then you can put things in y. Okay. So let's go. Okay. Fast forward through these steps. Okay. So I just did that. Now I go to line 10. Okay, now I'm going to do this second argument. Okay, remember, I've got the 8 here. Oh, notice how when I return to 13, it returned to line 8. Okay, so it returned from here to line 8. If we go back, see, I came from line 10. See, I was here, the second argument. I was at line 10 doing the second argument. The second argument is going to return 13. So 13 is going to go there, but it actually returned to not to line 10, it returned to line 8 because then it's going to go, see, then it returned to 8. So now it's got to do this call to F with that argument there and that argument there. The arguments are there, but we just don't see them. But we're now at this call to F. Okay. So we're at line 8. Okay. There's the arguments. They were 8 and 13. So we had an 8 there and a 13 there. Okay. So the return value. Okay. Now notice it should have returned to line 7 at this point because now that gets put into Y1, but it didn't even show it does that. It's kind of weird how it chooses what line to go back to. It would expect it from here to return to here because that's the next thing to do. But that's not what it chose to show. So here's the return value 55 from that one. Okay, so 55 is being returned for that one. When we go forward, we go back up to, well, see, we're coming from line 24, but we don't go back to line 8. You know, we were at line 8. Well, yeah, we go back to line 8, even though you'd think at this point we would go back to line 7. So it shows us going back to line 8, but then it skips over line 7. It doesn't show us the last step of that return value being put in Y1. Okay, so it just shows Y1 is 55. So it didn't go back to line 7. Okay, so you can trick the visualizer into showing you these sub-steps. Okay, but to do that, you have to write the code in a very funny way. Nobody would write their code that way unless they're debugging. Yeah, I mean, when I say nobody would write it that way, you wouldn't see it written that way. But in the process of trying to solve problems, of figuring out where mistakes might be, you might have somebody to fool the debugger into showing them more information, break their code up like this. I've done it in the past. Break the code up into pieces, each piece on its own line, so the debugger shows you when it's at that part and when it's at that part. Okay. All right. But from our point of view, what's important is to think this way, to think of this as being as lots of steps. Okay. Now, let's do one more thing with this. We got a couple minutes left. There's a mistake that people make a lot with methods. Let me write F a different way. Okay. I'm going to write an F2. I'm going to show you something it's a real common mistake. That's not really a good idea at all. This is not really doing a calculation for me. There's a huge difference between this and this. And the difference gets it's very, a lot of people seem to find it kind of confusing. A lot of people think of them as the same thing. Oh, this is giving me back a value. I see the value on my screen. But remember, I said, when you print something, it's not part of your program. This prints the value, but it's not part of your program. And notice that this is now wrong. This won't compile. It's not returning an int, it's printing an int. If I try to compile this, I get an error message. There's no return statement. I'm not returning something. So for example, F2 can't be used, like you can't do the following. You can't write F2 of 1, 2, comma, F2 of 3, 4. That doesn't make sense. That makes no sense to Java because F2 doesn't return anything, it prints something. F2 doesn't return a number, it prints something. So there's nothing to plug into this F2. This won't compile. I mean, this won't even compile. This is actually a void method right now because it doesn't return anything. And if I try to use it up here, I'll get an error message up there. Void type not allowed here. See, this F2 gives me back nothing. So there's no input to that F2. So this is not what we say composable. You can't actually use it for anything. Now it does print out answers, and that's where if you just think of a function as something that gives you an answer, if you think, oh, you write functions to get an answer, oh, here's the answer, I printed it for you, you might think that that's okay. And like on exams, a lot of times when I ask, where this shows up a lot is on an exam. I ask people, write a method that returns blah, blah, blah. Like write a method that returns 2x plus 3y. And people will write this and say, well, it printed what you want. But returning and printing aren't the same thing. Okay. It's returning and printing. They're not the same thing. Printing is actually not that useful. You'd be surprised how little printing real computer programs actually do. They don't print very much at all. Returning is the real key idea, because then I can do things like what we did here. The return value of that function can be input to that function. The return value from that is input to that. Or here, the return value from there can be added to the return value from there. I can't do that with F2. I can't say F2 of 1, 2 plus F2 of 3, 4. You can't add these either. Okay. This doesn't make any sense to Java because there's nothing on the left of this plus. F2 is a void function. It printed an answer, but it didn't give anything back that could be used in the plus. This thing didn't give anything back that could be used in this plus. This one didn't give anything back that could be used inside of this F2. There's no output here. Okay. There's no output there. There's no output from this one. So be real careful about this. Don't confuse returning with printing. Okay. Don't confuse those. In the exam that's going to be coming up in a week or so, this will be an important idea on the exam. Make sure you keep straight the idea. If somebody says write a function that returns something, don't use print line. Return means return an answer that can be used by the program. Printing prints an answer, but it can't be used by the program. It just appears on the output screen, and there's nothing that can be used further by the program. So it's real important to keep those straight. Returning and printing are very, very different. But I've seen textbooks that actually write things like this. Yeah, I've seen textbooks that you'll find books that teach programming this way. Write a function that prints that answer, and it can get confusing. I mean, it's a really common mistake to confuse returning with printing. And like I say, even some books, they misrepresent these ideas, and they'll write examples of functions that print their answer, you know, instead of return their answer, and that's really bad. Yeah, it can be confusing, and it's almost never useful. It's almost never useful to have a function that prints its answers. Okay, you want them to return answers, because the key idea is return values can be used by other parts of the program. Okay, so we've run out of time. Anybody got any question? We're going to start talking about arrays, and we're going to write methods with arrays. So we're going to keep talking about methods. Methods don't go away. They're the one thing that stick with us for forever in programming. So we're going to start talking about arrays, and we'll write methods using arrays. So we'll keep talking about methods, and we'll keep practicing using methods. Okay, so if you've got questions about the review problems, start looking at I got to put them, after class, I'll put them up on the website, and then start looking at them. And if you have questions about them, please ask. Okay. So we'll meet again on Thursday, and have a good day. Bye bye.